Good morning, algebra. So we are starting chapter 5, which is all about systems of linear equations. And you might say, well, what is a system of a linear equation? It's a set of two or more linear equations in the same variable. So x and y, c and n, two of the same variables. A solution to a system of linear equations is an ordered pair. So if you're using x and y, then it's going to be a coordinate pair x, y. So we're going to start with that and just seeing if we can figure out if these are a solution or if they are not a solution. It's basically a check. Remember way back in chapter 1 when we were just checking to see if it worked? That's all we're doing with these. And it needs to work for both of the equations, okay? If it works for one of them but not for the other one, then it's not a solution. So for our first one right here, and I'll see if I can zoom in. There we go, that's slightly better. We've been given the coordinate pair 2, 5, and we want to check to see if it works for our two equations. So I've separated them out, and all I'm going to do is plug in my x for the x's. So I'm going to put 2 in here, and then I want to plug in my y for the y's. So I'm going to plug in 5 here. And now I'm just going to focus, I'm going to focus on this one first and just see if it works. All right, so we have 2 plus 5. Well, that gets 7. Does 7 equal 7? Yes, it does. So that one is a solution for this equation. That doesn't mean it's a solution for the system. We have to make sure it works for this one too. So we've got 2 times 2, which is 4. And then we're subtracting 3 times 5, which is 15. And it needs to equal negative 11. This is not a check. You actually have to solve it all the way. It has to be the same number equal to the same number. Remember how I always said, can my 4-year-old see that's the same? Can my 2-year-old see that's the same? Well, 4 minus 15 in order matters. That gets us a negative 11. Is that the same? Negative 11 and negative 11? Yes. So this one, 2, 5, is a solution because it worked for both of them. All right, it is a solution because it worked for both lines. All right, let's check out this one. My tongue's tired this morning. So we've got negative 2 for our x. So I'm going to plug in negative 2 there and here. And then we've got a 0 for our y. And we're going to see if this one works. So we have 0 is equal to, well, negative 2 times negative 2 is a positive 4. 4 minus 4 is 0. Does 0 equal 0? Yes. So it's a solution for that one. And then for our next one here, we have 0 is equal to negative 2 plus 4. So that would be a positive 2. Is that true? No. So even though this point is on our first line, it is not for our second. So this is not a solution. So negative 2, 0 is not a solution. There's some more questions like this on page 135 of the Student Journal, questions 1 through 9. All right. Now today, you'll notice at the very top here, it said by graphing, right? By graphing, that's how we're going to solve these. So we're going to do at least 1, maybe 2, maybe 3 examples of graphing these. So the very first thing we want to do is just graph each equation. Well, how do we graph these equations? In slope-intercept form, it makes it really easy, right? We pick out what our intercept is. So let's start with our first line. Our intercept for this guy is 5. And I'm going to put a dot at my 5. So here's 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. So I put my y-intercept right here. I leave my pencil, and my slope says it's a negative 2 over 1. So that means I'm going down to right 1, down to right 1, down to right 1. And then I just need to connect this with a line. So I pull out my ruler. That way it's nice and straight. There we go. And remember, you want it to go edge to edge, right? Our graph goes edge to edge. And I'm going to make this one purple. I find it really helpful color. All right, it's it helps my brain. I'm also going to label this. Remember how back in chapter 3 I said, hey, when we start graphing multiple lines, it's really helpful to label them. So I'm going to label this guy as y equals negative 2x plus 5, because then I remember what the equation was. It's right there. It's easy for me to see. So let's graph our second one here. It's at negative 1 for the intercept. And then our slope is positive 4 over 1. So here's negative 1. And I want to go up 1, 2, 3, 4, and over 1. up 1, 2, 3, 4, and over 1. Remember, you could also go down 4, 1, 2, 3, 4, and left 1. So you have a couple different options. And then we connect it with a nice straight line, edge to edge. And I'm going to label this guy as my y equals 4x minus 1. And let's make him green. There we go. So now our second step here says to estimate the point of intersection. On this one, we really don't need to estimate. It's pretty easy to see. Every single system of linear equations, two lines, will have one point that they intersect. And you can see that, right? Our two lines intersect. They touch right there. That's it. That's their point of intersection. And we have to say, well, what is that point? This one, we really don't need to estimate it. We can look exactly at it. It's a pretty little star point. And it is at 1, 3. So now we need to say, well, did I graph it right? Let's double check. Hey, we're doing it again. So we want to check the point 1, 3 and see if it works for both of our equations. So we've got y equals negative 2x plus 5. And we have y equals 4x minus 1. So I'm going to plug in 3 for my y and 1 for my x. Oh, minus 1. 4 times 1 is 4. And then when you minus 1, you get 3. Does 3 equal 3? Yes, it does. So for this one, we have 3 equals negative 2 times 1 plus 5. Negative 2 times 1 is negative 2. When you add 5 to that, you get 3. Does 3 equal 3? Yes. So is this a solution? Yes, it is. Yes, it is. All right, let's check out 2 more graphs. All right, let's check out 2 more graphs. So for this one right here, we already have y equals x minus 1. So it's in slope-intercept form. Our slope is 1, and our y-intercept is negative 1. For this one, I actually have to solve it, so I need to add x on both sides. So we get y equals x plus 2. And now we know our slope is 1, and our y-intercept is 2. All right, so I'm going to start by graphing. We'll make this guy green. So I'm going to start by graphing him. So I'm going to start here at my positive 2, and I have to go up 1, right 1, up 1, right 1, up 1, right 1. And I'm going to draw my line. Again, make sure it goes edge to edge. A little off, not bad. If you choose not to label it, again, I'm going to highly encourage you to do your colors. Okay, do your colors. That way you remember which one's which. So that means this one I'm going to do in purple because those are the colors I grabbed. So we've got negative 1. And then we are going up 1, right 1, up 1, right 1, up 1, right 1. I like to do a couple. It helps me get a straighter line, that way I kind of know the general direction. Easier to connect it. And purple. So you might be looking at me going, wait a second, Ms. Frisch, you just said that every system of linear equations is going to have one solution, right? They're going to cross. That's their solution, wherever they touch. This one doesn't. Why is that? Well, it's because these are parallel lines. And we can see that right here, right? Their slopes are the same, so they're parallel. So there is no solution. All right, parallel lines have no solution. Which you're kind of looking at me going, well, duh, they don't cross. So that makes sense. Let's graph another one. Our first one here is already ready for us. We've got a slope of 2 and a y-intercept of 1. So we are going up 2 and right 1, up 2 and right 1, right? We start at 1. Ooh, we do that. Up 2, right 1. And then I can connect those. Oops. Tailed off kind of weird at the end there. Not bad. Not as straight of a line as I had meant. Let's do it in purple. All right, the next one, we want to, I'm going to add y on both sides because I think that's going to be easier to solve. So we have 2x plus 1 is equal to y. So that means we have a slope of 2 and a y-intercept of 1. So I'm starting here, and I'm going up 2, right 1, up 2, right 1. And you'll notice that those are, in fact, the same line. It's the same line. And now you look at me and you go, wait a second. They touch everywhere. They don't have just one solution. They have all solutions. They have all solutions. And that's because it's the same line. If I rewrite this, I get y equals 2x plus 1. Hey, look at that. That's the same as y equals 2x plus 1. They're the same line. All right. So I would say 9 out of 10 times you get something that looks like this. They cross, they touch there, that's their solution. But occasionally you get things that look like this, where they don't touch at all because they're parallel, or where they are exactly the same line. So, they have all solutions. All right, next thing we want to talk about is some word problems, because I know how much you love word problems. And oh, by the way, this is like real life, okay? So your family opens a bed and breakfast, like an Airbnb kind of a thing, right? Especially these days, to earn a little extra cash, and it's a military town, so we have lots of people coming in and out for short periods of time. They spend $600 preparing a room to rent. Okay. The cost to your family for food and utilities is $15 per night. They charge $75 per night to rent the room. Very reasonable, by the way. So let's just think about this. We want to write an equation for cost, and we want to write an equation for revenue. You could pick whatever variables you want. I'm going to go with x and y. So y is going to be my total, either spent or earned, and then x is going to be the cost per night or per day, either to me or to the customer. Okay, so for this one, for the cost, we know that we spent $600, right? And then we have to add $15 per night. So that means I have to add my 15x to that, right? Because every night I have someone stay, I have to have $15 for, their breakfast the next morning, and coffee and that kind of thing. So the revenue that we're making, well, however much we make is based upon earning $75 per night, right? Some places will also do like another charge, like you have to put, $5 down or something like that too. So you get $75 per night plus something. But this one is very straightforward. Like, this is how much you earn. That's it. All right, for our next one, we want to know how many nights will your family need to rent their bedroom before recovering the cost of preparing the bedroom. And this is what we call a break-even point. Oh, by the way, if you decide to open like a small business or something, like this is a big deal to banks. So, FYI. So let's count by 50s. Maybe I have to go by hundreds. 300, 400, 500. Ooh, I do. I have to count by hundreds. Okay, so there's 100, there's 200, there's 300, there's 400, there's 500, there's 600, there's 700, 800, 900, 1,000. All right. So I know that if I had someone stay for 10 nights, so y equals 15x plus 600. If I had someone stay for 10 nights, then I would have spent $150 plus $600. So that'd be $750. So that means I have the point 10, 750 for my cost equation. All right, for my cost. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not going to be enough. Let's do 5, 10, 15, 20, 25. I'm going to count by fives. Actually, I think counting by twos might be the best. Yeah, let's count by twos. So 2, 4, 6, 8, 10, 12, 14, 16. So this right here is the number of nights. And this is the cost or money earned or, that kind of a thing, right? So I know that I had to pay $600. So even if I don't end up renting the room ever, I'm out $600. And then the next question is, well, after 10 nights or of people staying there, I will have spent $750. So it should be right about there. Kind of have to estimate a little bit. Another way of saying that is, well, what if it was 20 nights? If it was 20, that'd be 20 times 15. That'd be 300. 300 plus 600 is 900. So 1820 would be at 900 right here. And those are nice, pretty points. So I can connect them. Beautiful line. And we could keep renting it out, right? I mean, we could rent it out all year long for years on end. And we're going to do that guy in, let's go with green. So then our next one here is the 75x. Well, that means that if I never rent the room out, I don't earn any money. If I rent it out for 1 day, then I'm at 75, which is about there. If I rent it out for 2 days, then I'm at 150. If I rent it out for 3, then I'm at 225. If I rent it out for 4, I'm at 300. So we can see that every 2 days we go up by 150. So this would be up here. And then this one would be here. So our nice pretty star points are the ones that work perfectly, right? The 300 and the 600. But you'll see, even if I rent it out for 8 days, I still haven't made up my cost. So the question is, well, when do we make up our cost? When is that break-even point? And we then start earning money and making revenue. So that break-even point is going to be right here. So it's at that 10 days, which, interestingly enough, I've already found. So that is our revenue, and it's this guy right here. So this is the y equals 75x, and this is the y equals 15x plus 600. So at one point, they need to rent out the room for 10 nights, right? For 10 nights, then they have their break even. They've made their money up for what they have spent. How many days would they rent the room and lose money? So that would be less than 10 days. If it's anywhere in here, right, our purple line is lower than, so that means the money that we've earned is always going to be less than the money that we've spent. So anywhere from 0 to 9 days, right, anything less than 10, we've lost money. So then the last question says, well, how many days would they need to rent the room to make money on the business, right? They don't make money at 10 days. That's when it's even. That's when the money they spent and the money they've earned are the same. To make money, they need to rent it for more than 10 days. And since you can't rent a room in small increments, right? Like you can't rent a room for half a day. This would be 11 days, right? So this would be 11 or more days. And that's when they would start earning money. And then they would earn it by whatever the difference is here. So like at 11 days, they had to spend another $15 for food, and they charged $75. So they actually only earn $60 a day more than what they cost or what they pay for it. So I hope that makes sense. Down here, we were really talking about domains and ranges. Hey, it's all coming back. Isn't that great? If you have any questions, please email me, ask me for help. I am happy to help you.